Now we will just go through transmission modes. Transmission modes, okay. How, in what mode data can be transmitted. Mode. This is not medium. Medium is nothing but on which the data is sitting and traveling. Okay. Mode is nothing but what is the mode of transmission? Let me explain. We have device A, we have device B. Now, in transmission modes, we have three forms of transmission modes. Okay, one is simplex, and second is half duplex. Okay, one is simplex mode of transmission, second one is half duplex, third one is full duplex. Now, what does it mean by all this? Let me come to simplex first. The mode of transmission, how transmission of data is taking place. In simplex mode of transmission, it's a type of transmission in which one device is only able to send data and one device is only able to receive the data. Simplex mode of transmission of data, either one device can send the data or one device can receive the data. They cannot do both. If this is a device, this can only send. This cannot receive. This should not be able to receive. Okay. And if this is a device, this should be only able to receive and it cannot send. Okay. Let me explain with an example. Suppose we have something called as monitor. Monitor can only receive the data. Got it? Monitor is a device which can only receive the data. Now, what is the device which sends the data to the monitor here? Example, CPU sends the data, right? Getting my point? We have monitor here, we have CPU here. Okay, server sitting here. This is sending the data to here. Okay, this is nothing but simplest mode of transmission. A type of transmission in which one device can either act as a sender either act as a sender or receiver, but not both. That is simplest mode of transmission. Example I told you, monitor, CPU, keyboard can only send. You know what simplex? Okay. Let me explain about half duplex. Here, duplex is nothing but sending and receiving. Okay. Half duplex is nothing but half sending and receiving. Not like that. Okay, I'm just joking. Okay, we have a device. We have a device. Okay, a device can act as both sender and receiver. B device can also act as both sender and receiver. Okay, but what's the difference? Then what's the difference between this and this? Half duplex is nothing but both can send the data, both can receive the data. But the case is not at the same time. Okay. If A is sending the data, B should shut up and listen at that time. Okay. Now A is first sending the data, B listens to the data. After some time, B will send the data and then A will listen to the data. Got my point? That is the thing about half duplex. The transmission of the mode of transmission of data in which any device can act as sender and receiver, but not at the same time t. Only one device can transmit the data at some time t. Okay, but the both cannot transmit and receive simultaneously. Okay, got my point? Example: you have seen in military organizations they use something called as walkie-talkie. What happens in walkie-talkie? You have something like a device called as phone. Why military people only use walkie-talkie and why not cell phones? Because they want to send the orders. Okay, they want to send the orders and listen to orders. Both people must not speak at the same time. That is the rule in military, biggest rule in military. Orders must not overlap. That's it. Orders must not overlap. Either one should speak or one should listen. We have something called as channel capacity. Okay, this you will not find in your college textbooks. Okay, channel capacity. What is channel capacity? Link capacity. Nothing but at some time t, at any time t, how many number of bits it can hold, okay, or how many number of bits it can transmit and at one particular unit of time, okay. This channel capacity is also particularly mathematically known as bandwidth delay product, BDP. Channel capacity is also known as bandwidth delay product. I told the definition at any particular instance of time how many bits or how many bytes it can transmit. Okay, nothing but in this is maximum link, but this is a link. Okay, this is a link. Okay, let's suppose this data is something but 10 MB of data. Nothing but this is channel capacity. What is channel capacity? Whole link is filled up with data. That amount of data is known as channel capacity. Okay, whole link is filled up with data. Now, what is the formula of this? What is the formula of this? As I told, the second mathematical abbreviation, bandwidth delay product. So channel capacity, nothing but BDP, is given by bandwidth into delay. Bandwidth is represented by R. Okay. Bandwidth. Bro, what is bandwidth? What is bandwidth? You have Wi-Fi in your homes. Okay. You have Wi-Fi in your homes. Whenever you take a subscription of any Wi-Fi, Jio, Airtel or Xnet or any of those, they show you something called as 200 Mbps, 100 Mbps, 30 Mbps. This is nothing but bandwidth. Mbps is nothing but bandwidth. Total number of data sent or the maximum amount of data that can be sent over a unit period of time is nothing but bandwidth. The maximum amount of data, that is nothing but bandwidth. They tell you, right, this much amount of speed. This is not speed. They are just, because you are common people, they are telling you this is speed of data. No, this is bandwidth. The total number of bits that can be sent over unit amount of time is nothing but bandwidth. Okay. Now, I told you bandwidth is 200 Mbps. Example. Now, what is delay? Delay. Suppose the length of the wire. Let's suppose the length of the wire is 10,000, not 10,000, it's too much. Let's suppose the length of the wire is 1000 kilometers. Delhi to Bangalore, the wire is connecting, okay. Now, you know the formula time is equal to distance by speed? Okay. Time is equal to what is distance? 1000 kilometers. 1000 kilometers. In meters is nothing but 10 power 3. 10 power 3 meters. SI units, we are running into SI units, okay. By speed, what is the speed of the signal? Tell me, any of you. What will be the speed of this signal in this optical fiber? Tell me. Will it be speed of light? The speed of data in the optical fiber. How much will it be approximately equal to? That will not be the speed of light. That will never be the speed of light. Speed of light is different. And the speed of data in the optical fiber or copper fiber, they are different. Okay, it's different. Okay, let me tell you. Let's not waste time, okay? So, the speed of light is 3 into 10 power 8 meter per second. Okay? But the speed of data in optical fiber is equal to 2 into 10 power 8 meter per second. It's just small amount of difference. Okay. It's not a small amount. I agree, it's a very huge amount. 3 into 10 power 8 and 2 into 10 power 8 is very, very huge. But if you compare through distance perspective, it's very fast. Like you can't see with your own eyes, right? Okay, now time is equal to distance by speed. Distance is 1010 power 3 and speed is 2 into 10 power 8. Now, this is nothing but delay. Delay is nothing but how much time will one unit of data take to reach from sender to receiver. That is nothing but delay. Delay is nothing but कितना time लग रहा है भाई मेरे को वहाँ पे जाने के लिए. How much time I'm taking to go there from here start to end. That is nothing but now. Note on this formula. Okay, border delay product is equal to R into T. T of delay. Okay. Bandwidth you can calculate. Bandwidth, you know, 200 Mbps, 200 MB per second. That's it. Into what is time? Time is nothing but this formula. You will get border delay product. That is nothing but channel capacity. Now, there are some special cases. There are some special cases in half duplex mode. So what basically happens is in ARQ mode, ARQ. What is ARQ? I will explain you in data link layer of OSI model. Okay. For now, think this model as the feedback model. Now, suppose A is transmitting, B is receiving. Okay. A sends the data, B receives the data. Now, I doesn't know whether he has received it or not. I am sitting in Bangalore, he is sitting in Delhi. I send the data. I never know that whether you have received the data or not. Okay? This is nothing but I'm just blind. I'm just blindly saying, okay, okay, it's like that. But in ARQ mode, what happens? Now, suppose A wants to send 6 frames. Okay? Suppose A wants to send 6 frames. What A will do? It will send first frame. It will just send 1 frame. Okay? And B will receive the frame. Now, B, after receiving that frame, it will send the acknowledgement frame back. ACK frame. Acknowledgement frame. So now, what A will do? It will not send its complete data. It will send only 1 unit of its data. Nothing but, what is frame? Frame is nothing but digital unit of transmission. How is frame formed? I will explain you in network layer of OSI model. Data link layer of OSI model. How frame is formed. Okay, don't worry about frame. Frame, for now you can think of frame as frame is a group of bits. Frame is a group of data, group of bits. Okay, arranged in some particular manner. Now A will send the data. Now B will receive that 1 frame. Okay, it will send ACK frame back, acknowledgement frame back. Now A, after receiving the ACK frame, it will send the remaining data, remaining 7 bits. Now in this case, okay, I told you delay, time of delay. Here, if you check, delay 1, delay 2, right? 1 frame is going here, delay 1. Another frame is coming back, delay 2. Next it will send here. Next it will send the data. Now here if you see, the formula will become R into 2 times of delay. Okay? This is for the case of ARQ. I'll explain what is ARQ. Okay. R into 2 times of delay. This is nothing but half-duplex transmission. Remember this thing? They'll sometimes ask in Google or Microsoft. I have read their interviews. I have gone through their interviews. They are asking this bandwidth delay product. What is the channel capacity and all. I have seen them asking these type of questions. Okay. Usually they don't teach this in colleges, and you will not even get anywhere. Okay, you know anything. Okay, now you understood what is half duplex, what is full duplex. Okay, so you understood what is simplex and what is full duplex. Now what is full duplex? You know the definition. A can act as both sender and receiver. B can act as both sender and receiver. Both can send and receive the data simultaneously at any time. Now, if A is sending the data, the B does not have to wait for send the data. It can send the data simultaneously. Nothing but bidirectional data transfer at any time. Okay? So, now tell me what will be the bandwidth delay product. This link can hold how much amount of data at a particular time. What is the maximum amount of data it can hold? How many bits it can hold? Bro, common sense. Let's not apply formula, common sense. Okay. Let's suppose the BDB is 1 lakh bits. Let's suppose, if you put the calculator and all, you'll get the exact value. So any, okay, 1 lakh bits, let's suppose. Now, in half duplex mode, we are just sending or receiving. At any amount of time, it can hold 1 lakh bits. Right? Now, common sense. If both are able to send and receive simultaneously, if this is a link capacity, now sending link capacity is 1 lakh bits. The retransmitting, a receiving link capacity will also be 1 lakh bits. Getting my point? Correct? If I'm not wrong. If the link is able to send this many amount of data at a time, as what I said, any device will not have to wait for any other device to send or receive. It can send simultaneously. So nothing but the link can send, or able to receive the data also. Okay? This is nothing but 2 lakh bits. 2 lakh bits, right? So the formula is nothing but 2 into R into time of delay. That's it. So friends, if you understood today's class completely, if you have understood today's lecture, please like the video, share the video, subscribe my channel. Thank you so much.